Hello to all my dear students in Faculty of Pharmacy, Cairo University, first year general class. I hope you have been doing well through the past 2 days in the other midterm exams, either in mathematics or also in botany. I hope it went so well, and I also wish you very good luck tomorrow in the organic exam. It will be very good. I trust you so much. I trust your abilities, I trust your understanding for most of the concepts in the organic chemistry. I think everyone has done so much effort during the process until we reach this stage before the midterm exam. I want you to be as calm as possible. I want you to just do your best, nothing more, nothing less. Just do your best today and make use of the time. Make very good use of the time. Every second, every minute, just do it. Today I'm doing this video because some of the students has asked me about illustrating the Curry House reaction, um, and I thought that it would be a very good idea to make it in a simple video and a very short one. In Curry House reaction, we actually convert alkyl halides into alkanes, so it's somehow a way for preparation of alkanes. It's a reaction between two reagents. The first one is lithium dialkyl copper with alkyl halide to produce alkanes. So, what again? Lithium dialkyl copper, alkyl halide to produce chain of carbon and hydrogen, which is alkane. Alkyl groups, if you know, alkyl groups are just like alkane, but minus one hydrogen. So, for example, it will be like CH3, this will be alkyl group, methyl, acyl, propyl, or whatever. Also, the alkyl halide, it has the alkyl group also, and the X. And the X here refers to the halogens. Halogens could be fluoride, chloride, bromide, or iodide. So it's actually obvious here in colors that this red alkyl group would react with this black alkyl group so as to produce this chain of alkane. Let's see an example here. Here we react lithium dimethyl copper with methyl halide. And as we agreed before, this halide can be chloride or bromide or any halogen to produce ethane. So let's notice something here. How many carbons are there in this alkyl halide? If you have noticed, per one molecule of alkyl halide, there will be only one carbon of the methyl group. Okay, and how many carbons are there in the ethane or alkane product? Exactly. There will be 2 carbons per molecule. So actually in this reaction, if I'm trying to describe this reaction, the number of carbons per one molecule is actually increasing from the reactant to the product, from 1 carbon per molecule into 2 carbons per molecule, which is actually called an ascending reaction. So what is ascending reaction? Ascending reaction is a reaction in which the number of carbons per molecule will increase through the reaction from the reactant to the product. And with the same idea, what if I told you that some other reaction is descending reaction? What would that mean? Exactly. Descending reaction would mean that the number of carbons per unit molecule is actually decreasing through the reaction from the reactant to the product. Okay, so the question now, how this reaction would happen? What would be the mechanism? What would be the way of it happening? Let's see that. So to know how this reaction is happening, we should actually notice this bond between the carbon and the copper here. While noticing this bond, I would like to ask you a very important question. Which atom would have higher electronegativity? Would it be the carbon or the copper? To remind you, the electronegativity is actually the ability of atom to attract electrons inside of the chemical bond. So if I am somehow stronger, if I am with high electronegativity, I would pull the electrons to my side, a little to my side. I will displace the electrons to my side. So which one would have higher electronegativity? From the periodic table, we know that the position of carbon is here, the position of copper is here, and the position of the halogens are here. And we also know that if you go from left to right in the periodic table, the electronegativity will increase. So from this way, the carbon would have higher electronegativity than the copper, as you notice here. So which one would attract electrons more, carbon or copper? Exactly. So carbon would displace electron or would attract the electrons to its side. And this means that this carbon would have partial negative charge, since the electrons are actually negatively charged. Okay, same way, in the alkyl halide group, which one would react? Which one would have higher electronegativity? The carbon or the halogen? Perfect. The halogens here would have higher electronegativity than the carbon, and this means that these halogens would actually attract the electrons to its side, will displace the electrons to its side, and this carbon of methyl group would have partial positive charge. By noticing what we have done, by noticing the electron movement, we understand now that this methyl group, which has partial negative charge, would absolutely react with partially positive other methyl group. And the reaction will go like this, and the halogen will go out, so as to produce the alkane chain as follows. In this example, we have different reactants. The first one is lithium dialkyl copper also, but this alkyl group is different than the one before. How would we call this alkyl group? Exactly. This alkyl group has a common name, which is isopropyl group. It's 3 carbon, so it's propyl, and it has the shape of 2 fingers and 1 arm. So it's called iso. So iso, what does iso mean? It's 2 fingers, just like this one, and 1 arm. So this one is iso, and because it's 3 carbons, it's isopropyl. But this is not only one isopropyl, it's diisopropyl. So it will be called lithium diisopropyl copper. Then we react this lithium diisopropyl copper with alkyl halide. And if you have noticed that this is acyl group, so this will be acyl halide. Again and again and again, this carbon would have partial negative charge because it has higher electronegativity than the copper, and this carbon would have partial positive charge because it has lower electronegativity than the halogen, which attract electrons from its side. So this one would react with this one, and the X goes out to produce a salt. So if I'm trying to draw the product, it would be like CH3, CH, CH3. This is from the red side. This is from the lithium dialkyl copper or the lithium diisopropyl copper, which would bind to CH2, CH3. There is one last thing. So as to make this reaction, so as to make it happen, we have to use a primary alkyl halide here, or methyl alkyl halide. So we can't use the secondary or tertiary alkyl halide. Only primary or methyl alkyl halide can be used with Corey-House reaction in the alkyl halide. There is another similar idea or similar reaction, which is called Grignard reaction. In Grignard reaction, it's almost the same. We have alkyl magnesium chloride, which reacts with also a primary or methyl alkyl halide, so as to produce alkanes. Can you pause the video and think for 1 minute? How would this reaction happen? Exactly. This R or alkyl group would attract electrons to its side because it will have higher electronegativity than the magnesium. It will have partial negative charge. And this alkyl group would somehow lose electrons to the halogen and it will have partial positive charge. Guess what? The partial negative would react to the partial positive and this X will go out to produce an alkane. This reagent is named after the great scientist. It's named as Grignard reagent. Thank you for watching. I hope that you made a lot of benefit from this video and I hope to see you soon. Good luck tomorrow. Thank you.